Now, again, a good question. Like this is more of a concept than a question, but yeah. So an object is having a velocity, something like this, 5 meters per second. Okay, at an angle of, this angle is 37 degrees. Okay, and it is falling like this, and this is the ground. Okay, now when it falls and jumps back, let's say it falls somewhere here, right? And when it jumps back, the velocity is uh, you say the velocity is v at an angle theta. Okay, you have to find v and theta such that for this ground, for the collision, the value of e is given as half. Okay, I'll solve this question. You understand the question? Pranav,
Yeah.
you have understood the question completely, right? So when the block is falling here, the initial velocity was what? 5 meters per second, like this, and this angle was 37 degrees. Am I right?
Mm-hmm.
And this is e half. Okay, now when it will jump back, that is what we have to discuss in detail. What would be happening here? Okay, so for that, again, this is what, this is a collision, right? So momentum would be conserved. Hello.
Yeah.
The momentum would be conserved for what point? See, when it is falling like this, like you can say that this is a gravity free situation. And even if it is not a gravity free situation, Pranav, this condition which I have drawn, this condition is valid only and only when the block is somewhere here. Okay, because when it will be falling with a velocity 5 meters per second, something like this, and it will be at some height, then with the descendant of this block, as soon as it falls, this vertical velocity will increase, right? Because there is a g acting to it,
Yeah.
acceleration due to gravity. Okay, so you have to consider that this condition that I have drawn, it is valid for this point only. Okay, here it is 5 meters per second, something like this, not at some height. Okay, or even if it is at some height, for example h, this is almost negligible. Okay, so when it, like, actually it is this condition, like it is 5 meters per second and it is at ground. Okay, so what will happen, because this is a collision, and when we are going to consider both of them to be a part of my system, then net force external would be what? 0. And this is my system, and this is my system. F net external is 0, right? It means momentum can be conserved in x as well as y directions. I'm considering these to be my x and y directions. Momentum can be conserved in both of the directions. Am I right?
Yeah.
Okay. So, but I guess momentum conservation won't even be required in order to solve this question now. And if you'll ask me why, because the coefficient of restitution is already given, and only upon this parameter is the final velocity of this block like dependent. With the final velocity, which we have to find out in this angle also, both of these things are completely dependent on this value only. Why? Because now let me just break down this into components. This is going to be 5 sine 37, am I right?
Yeah.
And this is going to be 5 cos 37. Okay,
Mm-hmm.
any doubts up until here?
No.
Okay. Now, if you just recall the formula for E, which is what? Coefficient of restitution. This is equal to what? Velocity of separation upon what? Velocity of approach. Is this formula complete?
Oh, this one. This, don't you have to get the line of impact?
Yeah, exactly. Yeah, full points for that. These two have to be along the line of impact only.
Because
Okay.
if it's not the line of impact, it wouldn't work, right?
Yeah. So that is why I have like made parts in the terms of components and all. Okay. Okay. See, now what is happening, that the formula for it requires the line of impact. But here, this is the velocity and this is the line of impact. Okay. The line of impact between a ground and a particle is always perpendicular to the ground. Okay. Let me write this here. Line of impact for an object and ground is perpendicular to the ground and passing through object's center, center of mass. Okay. Any doubts in this statement?
No.
Okay. So this is the perpendicular that we have drawn, right? It means this is the line of impact. It means this E value that has been given to us, when we are going to apply this in the formula, this velocity is what we are going to use. Am I right?
Yeah,
So this velocity would be what? Velocity of separation or approach? You tell me.
that would be the velocity of approach, no?
Yeah, because this ground, this is always going to be at rest. But this object, the velocity of the object is towards the ground. It means the object is approaching the ground. The ground is always at rest. So you just have to see the object. You just have to see the mass. The mass is the mass's velocity is towards the ground. It means it was approaching. So this is going to be here in the formula, right? But what would be velocity of separation? See, this is the condition just after the collision, right? And again, the line of impact here would be this. Am I right? Let me highlight the line of impact with a different color so that you understand it. So this is the line of impact, right? And again here, this was the line of impact. Okay. Any doubts?
No.
Okay. So the line of impact is this. It means when when this object is like moving in, when this object is like after the collision, this condition is right. So after the collision, when the object is moving with a velocity v in this direction at an angle theta with the horizontal, it means the component of velocities would be, here it would be v sine theta, am I right? And here it is going to be what? V cos theta. Is it okay for you, Pranav?
Yeah.
V cos theta and v sine theta. Okay. So it means the velocity of separation along line of impact is what? This ground is again at rest, but here the object's velocity is against the ground. It means it is separating. It is being separated apart from the ground. It means this v sine theta is the velocity of separation. Okay.
Mhm.
Any doubts?
No.
Very well. So let's apply this in the formula. E given is what?
Is
Half.
half, yeah.
Yeah. Velocity of separation is v sine theta. We have just seen, and velocity of approach is 5 cos 37 degree. This again we have just seen. Is it okay?
We cross multiply and solve for theta.
So what is 5 cos 37 degree? Cos 37 degree value, you tell me what is cos 37?
I remember you telling me this before.
Mm-hmm.
Cos 37 was it was, I remember it was like 4 or 5, right? 4
Very
fifths.
good, very good, very good. 4 over 5. So this will be 4. And this 2 will cancel this 2 times. It means v sin theta would be equal to 2. This is going to be what? 4.
Mhm.
So 2 times, it means v sin theta is going to be equal to 2. First equation. Okay, first equation with the coefficient of restitution. Right?
Yeah.
Now, for the second equation, what we are going to use, what I have told you, that since f net external is equal to 0, we can apply momentum conservation, right?
Yes.
Now, the ground is always at rest. Again, momentum conservation on what? System. We cannot say that the momentum of this block only is going to be conserved. The momentum, because on the system, the net external force is 0, right? Only on this block, it is not 0. But on the system, it is 0. So on the system, we can apply momentum conservation. Momentum conservation on system. Okay. In the x direction. Okay. So in the x direction, the initial momentum was what? Initially, this is the condition, right? So the ground is at rest. So whatever the mass of ground is, that we don't have to consider. Why? Because the velocity is 0, so the momentum of the ground is 0. Initially also and finally also, right? And the velocity of mass, let's say this mass is m. We don't know, but we are considering it to be m. Okay, so mass into what is the initial velocity in the x direction? 5 sine 37 degrees. Am I right?
Yeah.
This is equal to, what is the momentum along the final, again the ground is at rest, so whatever the mass of the ground is, even if it is infinite, it is being multiplied with 0, and this is equal to 0. Okay, now what is the final velocity in the x direction? V cos theta. See, right? So mv cos theta it would be mv cos theta. Is it right?
Yeah.
Now m will get cancelled out, and what is there that we are having? V cos theta is equal to 5 sin 37 degree. Now, let me tell you about a very beautiful observation. Since there was ground present here, since there was ground present here, you can see what is the result that came out after the momentum conservation, that V cos theta is equal to 5 sin 37 degrees. It means the x direction's velocity is finally is equal to the x direction velocity initially. Right?
Yeah.
It means the x direction velocity is never going to be affected after the collision, because this e factor, which is responsible, like the velocity of separation and the velocity of approach along line of impact, it means in the y direction the velocities are not same. Why? Because velocity of separation along line of impact is equal to e times velocity of approach along line of impact. Is that right?
Yeah.
It means the velocity of separation and velocity of approach are not equal to each other because of this e factor.
Yeah.
Right? If this e were equal to 1, perfectly elastic collision, then the
And that
velocity of separation would be equal to the velocity of approach. That also we have already discussed in the last lecture, right?
yeah.
It means the factor that does not like that does not allow velocity of separation and approach to be equal to each other, that is e, right?
Mhm.
The factor that does not allow velocity of separation and approach along the line of impact to be equal to each other is e, right?
Yeah.
Whether velocity of separation and approach along line of impact are going to be equal or equal to each other or not, that totally depends upon e. But what about x direction? Here, here, like this is the condition that x direction's velocities are simply equal to each other. That is because x direction does not participate in line of impact, first condition. And the second condition being that the second object that was a part of our system was completely at rest. Okay.
Okay.
So, like all in all, you just have to remember that whenever an object is colliding with uh, a floor or a ground or a wall, which is always going to remain at rest, then in
Mhm.
that case, that component of velocity which is not participating in the line of impact, right? This is completely along line of impact. This is completely not along line of impact. X is completely not along line of impact, and Y is completely along line of impact. Okay. So whenever
Yeah.
this happens, that an object like in our system, in our collision system, one of the objects is a wall which is not moving at all, or a ground which is not moving at all. Then in that case, that component of velocity which is not participating in line of impact, that always remains conserved. It means here velocity remains conserved. Again, momentum is conserved. It is not that velocity is conserved, but it is these are the conditions that are making the velocity to remain conserved, that we have derived from the momentum conservation equation. Okay.
Mhm.
So if you have written it down, I'll write it down also for you. Don't worry. So the second condition was this, and 5 sine 37 would be equal to what? What is sine 37?
Sine 37 was 3/4, right?
3 upon 5. Okay,
3.5.
3 upon 5. So this will be 3. It means v cos theta is equal to 3. Second equation. Okay. Now, how to eliminate theta out of these two equations? Any ideas? We'll square and add, because sine square plus cos square is going to be equal to 1. Okay.
Mhm.
Adding v square brackets 1. Y1 you are getting it, right? Sine square plus cos square.
Yeah.
It means v comes out to be under root 13 meters per second. And what about theta? Theta will be sine inverse 2 upon root 13 from this equation. Okay.
Okay.
Any doubts?
No.
So we have successfully found out what is v and theta, both of them. Okay. Let me write down the condition for you. When one of the objects in the collision is wall or ground, non-moving, then at least that component of velocity which is not participating in the line of impact thing will remain or will be conserved. Okay. See,
Okay.
I have added one more word here, at least. At least that component of velocity. It means both of the components of velocity can also be conserved. When the value of E would be equal to 1. When it is a perfectly elastic collision, if E is 1, then velocity of separation and approach along line of impact would also be equal to each other. It means y direction's velocity is again going to be equal to each other. Okay.
Mhm.
And isn't this exactly what we do in normal kinematics? When
Yeah.
object falls down like this, it bumps back from the ground with the same velocity, right? That we assume by ourselves. Is that right?
Yeah.
And but if the same thing is happening in real life, when you have, let's say, suppose you have a ball like this, okay, and when
Uh-huh.
you like release this, when it touches the ground, something like this, then when it again bumps up, it does not reach the same height. Am I right?
Yeah.
And when it again bumps down, it reaches even low height. Then like this, and then it comes at rest. Is that right?
Yeah.
Okay. It means that in real life, what we see, E is less than 1, right? Because velocity of separation is E times velocity of approach. The velocity of approach, when this falls down, the velocity of approach is what? Under root 2 GH, right? Or just think like this, that when it is like falling like this is falling with a greater velocity. And but when it again bumps up with velocity of separation again, this velocity with which it has fallen down was greater. It means velocity of approach was greater, and when it multiplies with the coefficient of restitution at the ground, it becomes lesser because coefficient of restitution is less than 1. So anything which gets multiplied with a value less than 1, its magnitude becomes lesser, right?
Uh-huh.
So the initial velocity of approach was very much. Then when it bumps back, multiplied with e, the velocity of approach becomes less. Therefore, with a lower velocity, it does not reach that much height from which it has
Yeah.
fallen down. Okay, and
Mhm.
then again same thing happens. Then it comes back to rest. Okay,
Yeah.
I did have a question based on the same thing, but I think that is going to be too much for you, and that is not going to be like any use to you. So I have
Okay.
just directly explained it to you what happens. So in real life, what we see is an example of partially inelastic collision. But in
Okay.
the questions that we do, that we assume that the ball is falling from this height and again it is reaching the same height. In that case, we are assuming the collision to be perfectly elastic. Okay, any doubts in any part from this whole lecture?
No. No.
Okay. So did you enjoy this lecture?
Yeah.
Okay. So again, I'm like requesting, I can just request that please revise all of the concepts. Okay. And in the next lecture, we are going to completely finish this topic off, and I'll also try to start the topic talk. Okay. Thursday evening lecture for you and Friday morning for me. Okay.
Mhm.
Okay. Thank you for joining, Pranav. Bye bye.
Yeah. Thank you.